All right, in this video, we're going to talk about Determinants and Cramer's rule. That's section 6.5 in the homework. Now, in this section, we're going to evaluate a second-order determinant, and then we're going to solve a linear system in two variables using Cramer's rule, and then we're going to evaluate a third-order determinant. All right, let's start off with what a determinant of a 2x2 matrix is. The determinant is a real number associated with every square matrix. And a square matrix, by the way, is this. You have to have the same number of rows and the same number of columns. Like a 2x2, 2 rows, 2 columns. Or 3x3, 3 rows, 3 columns. The determinant for a 2x2 square matrix is defined as follows, as given in the blue box here. The determinant of the matrix A1, B1, A2, B2 is defined by this notation. And it just has the vertical bars here. The matrix has the brackets. So a determinant will be the vertical bars for A1, B1, A2, B2, and it is defined by this. In this case here, it will be A1 times B2 minus A2 times B1. Okay, so here we can say that the value of the second order determinant is going to be A1B2 minus A2B1. Okay, so here's how we evaluate a second order determinant. We're going to find the difference of the product of the two diagonals here. So in this case here, the A1B2 is going to be this diagonal, the product of this diagonal going from the upper left to the lower right, minus the product of this diagonal, A2B1. That's the diagonal going from the lower left to the upper right. Okay. So that's how we find the determinant of a 2x2 matrix. All right, so now let's look at a couple of examples of this. And bring this down. Here we're going to evaluate the determinant of each of the following matrices. So like in part A, we got 10, 9, 6, and 5. And I want to evaluate its determinant. So the way I'm going to do that would be this. We take the product of this diagonal going from the upper left to the lower right. That's going to be 10 times 5. So what I'm going to do is just write it out so that you can see what I'm doing here. And then it's going to be minus. It's always going to be minus the product of this diagonal from the lower left to the upper right. 6 times 9. So I'm going to write that out. Now, if I multiply 10 times 5, that's going to be 50. Minus 6 times 9, that's going to be 54. And if I do 50 minus 54, I will end up with negative 4. So the determinant of that square matrix would be negative 4. All right, part B of example 1. We got 4, 3, negative 5, negative 8. And I want to find the determinant of that square matrix. Well, in this case here, we have to do the product of that diagonal from the upper left to the lower right. So in this case, that's 4 times negative 8. And then minus the product of this diagonal from the lower left to the upper right. That's going to be negative 5 times 3. And then we'll simplify. 4 times negative 8 is negative 32. Minus negative 5 times 3, that's negative 15. And then when I do negative 32 minus 15, that's the same as saying negative 32 plus 15, which will end up being negative 17. Okay, so the determinant of that square matrix in part B is negative 17. Okay. Now, here's very important that you understand how to do how to find the determinant of a 2 by 2 matrix, because that idea is going to be used when we solve a system of linear equations in two variables using determinants, which is the next thing we'll talk about here. Solving systems of linear equations in two variables using determinants. Here, determinants can be used to solve a linear system in two variables. This method of using determinants to solve a linear system is what we call Cramer's rule. Cramer's rule is what we're going to be using to solve a linear system in two variables here. So, in the blue box you see this. If you have a1x plus b1y equal to c1 and a2x plus b2y is equal to c2, then x is going to be this quotient right here, and your y is going to be this quotient right here. And that's provided that a1, b1, the determinant of that denominator, is not equal to 0. So now, on the next page, I'm going to explain what all of this means. These are just some helpful tips in setting up what x is and what y is. In fact, you're going to be setting up 3 determinants to find x and y. So the determinants in the denominators for x and y are identical, and the determinants in the numerator for x and y are going to be different. Okay, so here for the x is going to be equal to d sub x divided by d, and your y is going to be equal to d sub y divided by d, where the d, that's the determinant in your denominator, is not 0. Okay, so what does d is? What's d going to be? What d sub x is going to be? And what d sub y will be? Well, let's talk about d first. The elements of d, which is going to be the determinant in the denominator, are going to be the coefficients of the variables in the system. So here the a1 and the a2, that column represents the coefficients of x. And the b1, b2, that's the second column, that represents the coefficients of y. And now, for d sub x, excuse me if I can get this paper apart. Here we go. Now for d sub x, the determinant in the numerator of x is obtained by replacing the x coefficients in d with and that's a1 and a2, with the constants on the right side of the equations, which is your c1 and c2. Okay, so this is what d is. But with d sub x, we replace your coefficients of x with your constant terms, c1 and c2. So the first column are your constant terms after the equal sign. And the second column, where you got b1, b2, those are the coefficients of y. And I do need to mention that your equations have to have the x and the y on the left side and the constant terms on the other side before you can set up your determinants. If they're not, then you're going to have to move terms over to the opposite side in order to get all the x's and all the y's on the left side and the constant terms on the other side. And now for the d sub y. That's going to be the determinant in the numerator for y is obtained by replacing the y coefficients in d. That's the b1 and the b2 with the constant terms on the right side of the equations, which is c1 and c2. So there's d. In d sub y, the first column is your coefficients of x. But the second column, instead of the y, you'll replace it with your constant terms. Okay. So here on that page, you're going to be using those helpful tips in order for you to set up your three determinants, d sub x, and d sub y. Once you do that, then you can find the determinants for d sub x, and d sub y. Now let's look at a couple of examples of this. In this case here, we're going to use Cramer's rule to solve the system. In this case here, I got 2x minus 3y equals negative 11, and x plus 2y is equal to 12. And here I want to solve this system using Cramer's rule. Okay. So in this case, I need three different matrices. One for D, another one for d sub x, and the third one will be for d sub y. Okay, let's start off with the D. Your D is going to have x and y coefficients in each column. And notice here, your x's and the y's on the left-hand side, the constant terms on the other side. So I can write down d sub x, and d sub y. All right, now the x coefficients go in the first column. So these are your x's here. That's going to be the 2 and the understood 1. And make sure that you put those coefficients in the proper order. The 2 goes on top, 1 goes on the bottom. And then for the y's, your coefficients of y's, negative 3, 2. Negative 3 goes here, 2 goes here. And now for d sub x. Okay, this time, the first column will not have your x coefficients. It's going to have your constant terms. And then the second column will be your y coefficients. So in this case, here, your constant terms, instead of your coefficient of x, we're going to put in place of it the negative 11 and 12. Now the y coefficients, of course, are still negative 3 and 2. And then for the d sub y, the first column is your x coefficient, but instead of the y coefficients in the second column, we'll substitute those with your constant terms. So those x coefficients here are 2 and 1. And then the constant terms, instead of the y's, we're going to put the constant terms here, negative 11 and 12. Okay, now from here, we're going to go ahead and find the determinant of each one of those, d sub x, and d sub y. Let's start off with the d. If you recall, when we find the determinant, we do the product of this column, this diagonal from the upper left to the lower right first, minus the product of that diagonal from the lower left to the upper right. So if I do 2 times 2, that's going to be 4. And then minus the product of this diagonal from the lower left to the upper right. 1 times negative 3. That's negative 3. And now we do 4 minus negative 3, or 4 plus 3. That will be 7. So your determinant there will be 7. For D. Now for d sub x. Here we do the product of this diagonal from the upper left to the lower right. Negative 11 times 2. Negative 22. Minus the product of this diagonal from the lower left to the upper right. 12 times negative 3. Negative 36. And then negative 22 minus a negative 36, which is the same as negative 22 plus 36, will give me 14. And then for the d sub y, here we do the product of this diagonal. We're finding the determinant here. 12 times 2, that's 24. Minus the product of this diagonal from the lower left to the upper right. 1 times negative 11. That's negative 11. And then when I do 24 minus negative 11, that's 24 plus 11, which is 35. So now I got D, which is 7, D sub X, that's 14, and D sub Y, which is 35. Now I can use that to find out what X and Y are going to be. Here, the X is always D sub X divided by D. So here, D sub X, that's 14, divided by D, that's 7. So 14 divided by 7 is 2. So I know X is 2. Now I need to find out what Y is. That's D sub Y divided by D. Here, D sub Y is 35 divided by the D, which is 7. And 35 divided by 7 is 5. So here, X is 7 and Y is 5. So the solution to that system of linear equations is the ordered pair 2, 5. Okay, that's how we use Cramer's rule to solve this system. All right, here's another example. Say we had this. 5x plus 4y is equal to 12. 3x plus 6y is equal to 24. And here I want to solve this system using Cramer's rule. Okay. Well, first of all, my x's and y's are on the left side of this equation, of each equation, and the constant term is on the right side of that equation. So here, we can go ahead and write our determinants, or our matrices, for D, and then for D sub X, and D sub Y. Now for the D, of course, those are the coefficients of X and Y. And in this case here, your X coefficients are right here, 5 and 3. And then your Y coefficients are 4 and 6. And then for the D sub X, well, instead of your X coefficients going in the first column, your constant terms go in that column. And then your Y coefficients in the second column. So here your constant terms in this case are 12 and 24. And then your Y coefficients are, in this case, 4, 6. And then finally for D sub Y, the first column is the X coefficients, but instead of the Y coefficients going in the second column, your constant terms will go in place of it. So your X coefficients are 5 and 3. The constant terms are 12 and 24. So those are my matrices for D, D sub X, and D sub Y. Each one of those, we're going to find the determinants. Starting with the D. So let's start with the 5 times 6. Upper left to lower right, its product is 30. Minus this diagonal's product from the lower left to the upper right, 3 times 4. That's 12. 30 minus 12 is 18. So for D, its determinant is 18. And then for D sub X is this. We do 12 times 6, that's 72. Minus 24 times 4, that's 96. So for D sub X, 72 minus 96 would be negative 24. And then for the d sub y, we do the product of 5 and 24, this diagonal here, that's 120, minus 3 times 4. 3 times 12, that's 36. So 120 minus 36 will leave me with 84. So that's what d sub y is. So now d sub x is 18. Well, d is 18, d sub x is negative 24, and d sub y is 84. I can use those to find out what x and y are going to be. So x is equal to d sub x divided by d, which means d sub x, that's negative 24, divided by the d, which is 18. So I got negative 24 over 18. I can reduce that by dividing the numerator and the denominator by 6. So I know that's negative. 6 goes into 24 4 times, and 6 goes into 18 3 times. So x will be negative 4/3. And then for y, that's d sub y divided by d. Well, your d sub y is 84 over your d, which is 18. So that's 84 over 18. And again, I can divide the numerator and the denominator by 6. I'm taking the largest number that goes into 84 and 18. So that means 6 goes into 84 14 times, and 6 goes into 18 3 times. So y in simplest form would be 14/3. So that means the solution to that system will be negative 4/3, 14/3. Okay. And sometimes your order pairs could end up in a fraction like what I got here. All right, next we'll look at inconsistent and dependent systems. Sometimes your system of equations could be inconsistent. Sometimes it could be dependent. The ones that we did were consistent and independent. All right. So here, the first rule is this: if d is equal to 0, that's the determinant in the denominator, and at least one of the determinants in the numerator is not 0, then the system is inconsistent, which means your solution set would be, in this case, that's the notation for the empty set. The circle with the slash, meaning the empty set. And the second rule says if d is equal to 0 and all the determinants in the numerator are 0, then the equations in the system are dependent, meaning that the system will have infinitely many solutions. Okay? So if we look at example 4, we're going to use Cramer's rule to solve this system. We got 3x plus 3y is equal to 2, and 2x plus 2y is equal to 3. So in this case here, just like we did in the other examples, excuse me. Just like in the other examples, we're going to do d, and then d sub x, and d sub y. All right, in this case here, your d is going to be your x and y coefficients, as you should know. Here are your x coefficients here, 3 and 2. And your y coefficients are also 3 and 2. All right, and by the way, the x and the y are on both sides, on the left side of the of each equation and the constant terms on the other side. So we can do this. D sub x has the constant terms in the first column and the y coefficient. So your constant terms are going to be 2 and 3. Your y coefficients are 3 and 2. And then d sub y, first column is the x coefficients, but this time your constant terms in the second column. So your x coefficients are 3 and 2. The constant terms are 2 and 3. In this case here, let's find the determinants for each one of those. For the d, we do 3 times 2, that's 6, minus 2 times 3, that's also 6. 6 minus 6, that's 0. So it's either going to be inconsistent or it's going to be a dependent system, one or the other. And it depends upon what d sub x and d sub y are going to be. So let's find the determinants for those. D sub x is this, 2 times 2, that's 4, minus 3 times 3, that's 9. 4 minus 9 will end up being negative 5. And if you want to go ahead and carry this out, d sub y, find d sub y, 3 times 3 is 9, minus 2 times 2, that will be 4, and 9 minus 4 is 5. Now you can see here that your determinant in the denominator, that's your d, that's 0. D sub x and d sub y are not 0. So that means, in this case, we're going to have an inconsistent system. So that means the solution set is this, the empty set. And you would know that you're going to have an inconsistent system because if you try to find out what x is, which is d sub x divided by d, your d sub x was negative 5 and your d is 0. We can't divide by 0. That's undefined. And it's similar if you did y equal d sub y divided by d. Here your d sub y is 5 and your d is still 0. The denominator is 0. We can't divide by 0. That's undefined. So that tells you have an inconsistent system. The solution set there would be the empty set because there is no ordered pair for x and y for that system. All right, let's try this one. We got x plus 2y is equal to 3, and 4x plus 8y is equal to 12. In this case, the x and the y are on the left side, the constant terms are on the other side for each equation. So let's find out what d is. Set up our matrices for d and for d sub x and for d sub y. Of course, your d is always the x and the y coefficients for each column. So here your x coefficients are right here, the understood 1 and 4. Your y coefficients here are 2 and 8. And then for the d sub x, instead of the x coefficients, the constant terms go here, the y coefficients go there. So the constant terms are 3 and 12. The y coefficients are 2 and 8. And then for the d sub y, the x coefficients go in the first column, the constant terms in the second column. So your x coefficients are 1 and 4. The constant terms are 3 and 12. Now we're going to find the determinants for each one of those. So here, the determinant for D. This will be 8. 1 times 8, that's 8. Minus 4 times 2, that's also 8. 8 minus 8 is 0. So we know it's either going to be inconsistent or it's going to be a dependent system. It depends upon what d sub x and d sub y are going to be. So let's find out what d sub x is. In this case, 3 times 8, that's 24. Minus 12 times 2, that's 24. 24 minus 24 is 0. And then for the d sub y, here 1 times 12 is 12, minus 4 times 3, that's also 12. 12 minus 12, that's 0. So as you can see here, your d sub x, and d sub y are all equal to 0. So that means that this system is considered to be a dependent system. That's a dependent system. And if it's a dependent system, that means that there are infinitely many solutions. Okay. So that's how we apply Cramer's rule to solve systems of linear equations in 2 variables. All right, now let's look at this right here, the determinant of a 3x3 matrix. Associated with every square matrix is a real number called its determinant. The determinant of a 3x3 matrix is defined as follows. So here is that definition of what that 3x3 matrix is and what it looks like. 3 rows, 3 columns. And now, if you look at this, you're going to see the procedure for evaluating a 3x3 matrix. Okay. First things first, you're going to rewrite the first 2 columns of that matrix here. So as you can see, the first 2 columns of that matrix were rewritten. And then the determinant will be the sum of the first 3 products of the diagonals from the upper left to the lower right. This product, which is this, plus this product, that's this, plus this product, which is going to be that. And then we're going to minus or subtract each product of the next 3 diagonals from the lower left to the upper right. So it's going to be minus the product of this diagonal, minus the product of the second diagonal, minus the product of the third diagonal. Okay. And that will give you the determinant of that 3x3 matrix. So, in this example, we're going to evaluate the determinant of the following matrix. Here we got 2, 1, 7, negative 5, 6, 0, and then negative 4, 3, 1. So here's what I'm going to do here. First of all, I'm going to rewrite the first 2 columns of this matrix. So I'm going to rewrite the first column, which is 2, negative 5, negative 4. And then the second column, I'm going to rewrite that, 1, 6, and 3. Okay, so now, this is what I will do. I'm going to take the product of this diagonal from the upper left to the lower right, and then add to it the product of that diagonal from the upper left to the lower right, and then add to that the product of this diagonal from the upper left to the lower right. So I'm just going to add. Well, actually, I'm going to have to multiply and then add the products together. So let's start with multiplying 2 times 6 times 1. That's 12. And then plus the product of this diagonal. 1 times 0 times negative 4. Well, that's 0. And then plus the product of this diagonal. 7 times negative 5. That's a negative 35 times 3, which is a negative 105. Now, the other diagonals from the lower left to the upper right, I'll be subtracting. So I'm going to be subtracting the product of this diagonal from the lower left to the upper right, and then minus this diagonal from the lower left to the upper right, and then minus the product of this diagonal from the lower left to the upper right. So I have minus the product of negative 4, 6, and 7. Well, negative 4 times 6, that's negative 24. Negative 24 times 7 would be a negative 168. Yeah. And then minus whatever the product of this diagonal here is going to be. 3 times 0 times 2. Well, 3 times 0 is 0. 0 times 2 is 0. That's easy. And then minus the product of this diagonal. 1 times negative 5 times 1. Well, that's negative 5. All right, so I'm done with that. So what I'm going to do is try to clean this up a bit. Got 12. Now I can say plus negative 105 would be like minus 105. And then minus a negative 168 would be plus 168. Minus a negative 5 would be plus 5. So this is what I have left. 12 minus 105 plus 168 plus 5. And if you were to do all of that, type that in the calculator. So I'll go ahead and do that now. Okay, here we go. If I do 12 minus 105 plus 168 plus 5, I would end up with 80. So the determinant of this 3 by 3 matrix would end up being 80. Okay. So that's how we use that procedure to find the determinant of any 3 by 3 matrix. Okay. Now on the next page is a different approach for finding a determinant of a 3 by 3 matrix. They use what they call expansion by minors. Expansion by minors. Now in this case here, they're using the first column. A1, A2, and A3. Okay. Those will go on the outside. And I'm going to show you how they get the square 2 by 2 matrices here. Okay. So the first step, each of the three terms in the definition contain 2 factors, a numerical factor and a second order determinant when you're expanding by minors. And then number 2, the numerical factor in each term is an element from the first column of the third order determinant. And then the minus sign precedes the second term. Now I'll explain why that's a minus and that's a plus. Here they're alternating plus, minus, and plus. And then the second order determinant that appears in each term is obtained by crossing out the row and the column containing that numerical factor. So if we're dealing with A1, that's the element in the first row, first column. We cross out the first row and the first column. And what's left would be the square matrix. B2, C2, B3, C3. And then, of course, A2, that's in the second row, first column. The first column is crossed out. The second row is crossed out. You're left with the B2, C3, B3, B1, C1, B3, C3. And then this next one is a plus A3 times that. A3 is in the third row, first column. The first column in the third row crossed out. You're left with B1, C1, B2, C2. Okay. So the minor in the element is the determinant that remains after deleting the row and column of that element. For this reason, we call that method expansion by minors. Okay. And then there is a study tip here. So if you can remember this first row, first column of that element would be a plus. Then the next one would be minus and then plus. Now if you go in column, then it's plus, but then it's going to be minus after that and then plus after that. It's just alternating plus and minus symbols, plus and minus signs. Okay, take a look at example 7. And in this case, we're going to use expansion by minors to find the determinant of that 3x3 matrix here. Here we got 1, 1, 1, 2, 2, and 2, -3, 4, and 5. Now, in the directions here, what they're saying, they're using the first column of that third order determinant. You can use any column. You're not limited to the first column. You can use any column. In this case, I'm going to use the first row. These elements in that first row will be on the outside of the 2x2 matrix. Okay, because 1 times anything will be whatever. Okay, so starting with this row right here, I know that's a plus, this will be minus, and that's going to be plus. We're alternating plus and minus signs here. So here, this 1 would be here on the outside. Now what's going to go on the inside is this. That 1 is in the first row, first column. So I need to eliminate the first row and the first column. And I'm going to have to use my pens for this one to cover the first row and the first column. You're going to see you're going to be left with 2, 2, 4, -5 when you eliminate the first row and the first column that this number is in. So I have a 2 and a 2 and a 4, -5. Now, this is a plus 1. The next will be a minus because we're alternating plus and minus signs here. And then I'm going to use that first row here. Those will be my numbers on the outside of the matrix, of each matrix. This 1 will be on the outside. And that 1 is in the first row, second column this time. So I'm going to eliminate the first row. This time the second column. So you're going to see we're going to be left with 2, 2, -3, -5 for my 2x2 matrix. So in this case, I'll be left with 2 and 2, -3, -5. So this is plus, that's minus, this last one has to be plus. And then the 1. Now that 1, this third 1 right here is in the first row, third column. So cover up the first row. Okay. Cover up the first row. Cover up the third column. You're going to be left with 2, and a 2, and a -3, and 4. 2, 2, -3, and 4. And now we're going to take the determinant of each of those 2 by 2 matrices here. Here I'm going to bring down the 1. That's going to be multiplied by this. 2 times -5, that's -10. Minus 4 times 2, which is 8. And then minus 1 times the determinant of this matrix. 2 times -5, that's -10. Minus -3 times 2, that will be -6. And then plus 1 times, here I'm going to use 2 times 4, that's 8. Minus -3 times 2, -6. So in this case here, if I bring down this 1 times and then simplify -10 minus 8, that's -18. Minus 1 times -10 minus a -6, that's like -10 plus 6. That's -4. Plus 1 times 8 minus a -6, that's 8 plus 6, which is 14. Now, 1 times -18 is -18. Minus 1 times that -4 would be a plus 4. And then 1 times 14 would be 14. So in this case, if I do -18 plus 4, that's -14. -14 plus 14 will end up being 0. So the determinant of that 3 by 3 matrix using expansion by minors would end up being 0. Okay. All right, here's another example. Using expansion by minors, I want to find the determinant of this matrix. 2, -4, 2, -1, 0, 5, 3, 0, 4. Now, my recommendation for this one is to use the row or the column that has as many zeros in it. And I'm going to use this middle column. Because notice I got zeros here. And I only got the -4. But I need to know the signs I'm going to be using here. Because notice in the study tip, if you go row by row, it's going to be plus, minus, plus, minus, plus, minus, and then plus, minus, plus. So this middle column has a minus and a plus and a minus. So here's that study tip again. That second column is a minus, then a plus, and then a minus. So I'm going to start off with a minus or negative. That 4 is negative, so bring down the -4. That's going to be multiplied by, that -4 is in the first row, second column. So if I cover the first row and the second column like this, you're going to see I have -1, 5, 3, and 4 as the 2 by 2 matrix. -1, then 5, 3, and 4. Now this was a negative or a minus, so the second one has to be plus. Now notice here, I have a 0 here. So this will be 0 times. Now that 0 here, this first 0 is in the second row, second column. So I need to cover the second row and the second column. If I eliminate that, and I might need to use a highlighter for that, since covering the second row and the second column, the parts that are not highlighted are 2, 2, 3, and 4. Okay, this is minus, then plus, and then the last would be minus. this 0 is in the third row, second column. Now I think I can cover that up using my markers here. Cover up the third row and cover up the second column where the 0 is in. This is what I'm going to have: 2, 2, -1, and 5. Okay. And now we can find the determinants here. All right, that minus a -4 would be a +4. And then that's going to be multiplied by this. -1 times 4 would be -4, minus 5 times 3, which is 15. Now this is why I use the second column because of these zeros here. I don't care what the determinant for this matrix is going to be, because it's going to have to be multiplied by 0. That's going to give me 0. And then minus, here I could care less what this determinant is, because it's going to be multiplied by 0. That's also 0. Okay. See how important it is for you to use the row or the column that has as many zeros in it? Okay. So now, the only thing I need to do is find out what this is. -4 minus 15 would be -19, and then -19 times the 4 will end up being -76. So the determinant of this 3x3 matrix would be -6. Okay. So that's one way of finding the determinant of a 3x3 matrix. The other method, and this is the spoiler alert, you can use your graphing calculator to do this, and you have to know how to use it properly in order to find the determinant of that 3x3 matrix, following that 9-step procedure here that you see here. And we use the command DET for the determinant. Okay. And for the sake of time, instead of reading all these rules here, we'll use them to find the determinant of this matrix below. Here we got 3, -1, 2, -2, 4, -3, 4, -2, 5. Okay. So here is the procedure. I'm just going to follow that procedure here. So the first step on the graphing calculator, you're going to access the matrix menu by pressing second and x to the -1. So here's second, and then x to the -1 would be right below the math key. Now you're going to enter a new matrix, so here you need to use your right arrow key to edit. And I'm going to store this in matrix A. So I'm going to select number 1 for matrix A. Now, keep in mind this is a 3x3 matrix. 3 rows, 3 columns here. So this right here are your dimensions. The first number is the number of rows. The second number is the number of columns. So we type in the 3 for the number of rows and then enter. And then type in the number 3 for the number of columns because it is a square matrix. And then the next step is to type in each number row by row, pressing enter after each number, like we did when we did matrices in the calculator in the last video. So in this case, I'm going to type in the 3 and then enter. -1, enter. 2, enter. -2, enter. 4, enter. -3, enter. 4, enter. -2, enter. And 5, enter. So you have to press enter after the very last number in the last row in the last column as well. The next step would be to get out of this matrix menu by pressing the second and the mode key. The second key is the blue key, and then the mode key is right next to it. It takes you back to the home screen. And then we're going to press second and then X to the -1 underneath the math key. Hit your right arrow key to go to math. And then press it down. Well, actually, DET is the first item at the top. DET means determinant. So I will select menu item number 1. It gives you DET and then the left arrow. Now I want that matrix that I saved in this calculator here. So here I'm going to do second X to the -1. And under the names menu, I'm going to choose this first one, which is matrix A. That's where I stored it. And then close the parentheses. And then finally press enter. It will give you the determinant of that 3x3 matrix, which is in this case 20. So the determinant of this 3x3 matrix is 20. Okay, so that will conclude this video for section 6.5 dealing with determinants and Cramer's rule. Now the homework for that will be available for you on my math lab, or should be available for you on my math lab. Also feel free to email me if you have any questions about the homework. Do check Canvas for any announcements that I posted there. And also check your email for anything that I might send to you about important things.